suppose I'll get one of our trolleys with a spring at the end, and I'll put one of the magnets on the back of the trolley, and I'll see if I can drive the trolley from a distance. Oh, wrong way round. So between these two magnets there's obviously a bit of interaction, a bit of force. So let's just turn them like that. So the north is facing the north. And they should repel. And that, I can feel the push there. So that, about 6 centimetres. Turn it over, so they attract. Let's put them 6 centimetres apart and see what happens. Stuck together and difficult to break apart. So what does that force look like? So what I'm going to do first, put them north to north and put a piece of styrofoam over the top, put some iron filings in a pepper pot, and let's see what happens. Right, I've cleared all the iron filings above this magnet. It's just underneath. You can see there's a few left, but nothing dramatic. And I'm going to sprinkle and watch the pattern build up. You can see here it's like a little forest at the back. Let's see if I can get some. Then I'm going to, you see the lines of force. So that you can see the forces around the magnets. So what I'm going to do now is just get this bit covered. So you can see all the lines really clearly there. Oh, a bit more there. And I'm going to turn this magnet through 180 degrees. So at the moment you've got, I think, a north to north or a south to south, doesn't really matter. We're going to switch one round and see what happens. Now you can see there's iron filings in the middle. So it's just like stroking a cat. Oh, I think the magnets have stuck together underneath. So you can see there the lines of force going around. They've all swapped around a bit. But you can see the lines out here. And I'm just going to zoom into that bit. You can see here, like hair. Not my hair though. So the lines of force aren't just flat, they're also sticking out upwards and going out into the air. So magnets do this and it's really cool. Right, another way of showing this is with paper clips. If I just start chucking paper clips in. And they get them lined up, the lines of force. You can see them, if we put them gently, just stand them up. Let's see if I can attach another one to that one. So some metals are magnetic, and a good sort of magnetic detector is a compass. So look in here, that's supposedly north. I'm not sure it actually is, but if I bring this little mini sort of pliers thing close to it, it doesn't react to a little tiny reaction. Okay, that is north actually, that's pointing north, but it's going back somewhere else. If I bring it close, so iron and steel, yeah, that's attracting it. So what I'll do is I'll get this, and this is what you're going to make in a while, something similar to this. And if I put that, yeah, that's definitely magnetic. And if I turn it round, yeah, so this is a south pole because it's attracting the north, so that must be a north pole because it's attracting the south. And if I bring my scissors close, yeah, they've also been there. I've got magnets around, so everything ends up getting magnetised. So we're going to make an electromagnet. Now, what you need is a lump of metal, iron. So you can test its iron by putting it next to a magnet, and if it sticks to a magnet, then it's iron. Now, what you need to do is wrap it up in wire. So I've nearly finished this one, so I'm just going to tidy up the end. And this is going to become my magnet. So we're making an electromagnet. So I'll just wrap it up nice and neat. Now you need some wire left at the end so it can roughly meet, so when we wire it up to a battery or whatever you've got at home, that those two aren't touching but you can get to the same place. So I'm just going to tape it up a little bit so the wire doesn't fall off and get all really messy. You can use sellotape or bandages or string or glue or anything. All that's doing, just stopping it unwinding all the time. So that's going to be our electromagnet. Now at the moment it's a little bit magnetic, but hardly at all. It's enough for this to detect it, but not strong enough for iron filings to pick it up. So we're going to use a transformer. You can use batteries for this. If you've got a transformer, absolutely brilliant. I've used phone transformers in the past. I've used all kinds of bits and pieces. But obviously if you're using electricity, make sure you know what you're doing. At the moment, this is magnetic because the compass picks it up, but it's not very magnetic because the iron filings don't react. So what I'm going to do is run electricity through the coil and see what happens. Turn it on, so we're on 1 volt. Little tiny, let's go up 2. So that has turned into a magnet. So that end is definitely a south pole. Okay, now what I'm going to do is unplug the red and the black, turn it off, plug it back in. So that's the south pole at the minute. Swap the wires round and that becomes a north pole. So by reversing the flow of the electricity changes what end of the magnet we've got. So let's try that again. Unplug that, plug it back in the original way round, turn it back on, and the polarity of the magnet has reversed again. So there's a couple of things to investigate with electromagnets when you get to make your own. One of them is how many iron filings can it hold? How much mass can it take? And if I turn it off, it stays magnetic. Okay, some things to investigate. So you need some kind of electricity. Batteries work just fine. You need something made of metal and you need some wire. And you can make your own electromagnets. I want to see how powerful you can make them.